Welcome to our sixth lesson. In our last session, we laid out the complete architecture and design for our search system. Today, we're moving from that blueprint to reality. We'll look under the hood to see how we actually built the system, the specific programming languages, frameworks, and tools we use to bring our ideas to life. As a quick reminder, our system's blueprint is built on three key services that work together. First, we have the distributed query service, or orchestrator, which is the central brain. Second, we have the LSH component, or the local expert, which is deployed at each data source. And third, we have the re-ranker, or curator, which is a smart filter that perfects the final results. Now, let's see what each of these is actually made of. To build our system, we chose a set of modern, practical, and powerful tools. We selected Python as our core backend language, mainly because of its unparalleled strength and ecosystem for data science and machine learning. The full stack includes Python for the backend, Flask as a web and API framework, scikit-learn and Keras for machine learning, and Vue.js for our front end. We took a modular API-driven approach. All three of our backend components, the orchestrator, the LSH component, and the re-ranker, were built as independent microservices using Flask. Flask is a lightweight Python framework that's perfect for creating simple and fast APIs. This microservice approach means that each component is its own self-contained application. They all communicate over the network, which makes the entire system modular, scalable, and much easier to maintain and update. Now let's take a closer look at the LSH Components API. To allow all our services to communicate reliably, we defined a clear contract for them using the Open API specification. The LSH Components API really has two main jobs: handling the datasets themselves and searching them. To do this, it exposes two primary endpoints. One at /dataset for managing a specific dataset, and one at /search for performing the content-based search. The /dataset endpoint is crucial for keeping the search index synchronized with the data. When a new dataset is added, a POST request is called. This triggers the index creator to generate the LSH hashes for that new content and store them. If a dataset is updated, a PUT request regenerates its hashes to ensure the search index always reflects the latest version. And naturally, when a dataset is removed, a delete request deletes its corresponding hashes from storage, ensuring it no longer appears in search results. The second endpoint, /search, is the core function used by the orchestrator. Using a POST method, the orchestrator sends the query data, like the content of a file, for a query by example search. The LSH component receives this, searches in its local index, and returns a simple JSON object containing a list of matching dataset UUIDs. This simple, fast API allows the orchestrator to efficiently query every single distributed LSH component in parallel. Now for the machine learning engine. The intelligence of our re-ranker was built using industry-standard ML libraries. First, we used scikit-learn, a powerful library, to implement our simple teacher model that was based on our expert rules. Then we used Keras, a user-friendly deep learning library, to train the more complex student model, which learns its nuanced understanding from the teacher's examples. This training process all happens offline. The final trained model is then simply loaded by the re-ranker's Flask API, allowing it to provide fast, online scoring for live search queries. Finally, let's talk about the user interface. The front end is the part of the system that the user actually sees and interacts with in their web browser. For this, we used Vue.js, a modern JavaScript framework. It allowed us to build a clean and straightforward user interface for the two key functions: uploading a sample dataset to perform a query by example search and displaying the final, ranked list of results that our system returns. We successfully translated our architectural blueprint into a real functioning system using a modern technology stack. A modular backend of Python and Flask microservices provides a robust and scalable foundation with well-defined APIs. Scikit-learn and Keras infuse our system with the machine learning intelligence needed for high-quality ranking. And Vue.js delivers a clean and effective user experience. This implementation demonstrates a practical and efficient approach to building sophisticated, content-based search capabilities. Thank you very much for your attention. As always, if you have any questions, please feel free to send us an email.